Hello students, I'm going to record an answer key for the test. Put your last initial on things, please. All right, this says dilate the triangle with FEG with center C and a scale factor of 2. A good way to start this one is to go from the center of dilation out through the vertices of the triangle. And now if I had a compass, I would open it to that amount and then I would double it. If I don't have a compass, I can measure. And this looks like it's about 1 centimeter, so I can go out another centimeter, or I can just go out to 2 centimeters right here. That's going to be E prime. That's the image of E. From C to G is a little bit longer. It's like 1.3. You can go out another 1.3. About to there. That's G prime. That's the image of G. And then from F to C, that's 2.8 centimeters, maybe 2.7. So I need to go out another 2.7. Oh, I need to extend this ray a little bit further. And then try that again. Okay, about there. So F prime is out there. So I have now doubled the distance from C to the 3 points of the triangle. Now I can draw my triangle. That is the triangle FEG dilated by a scale factor of 2. And it is twice as big. That's how you do that one. All right, let's look at the next one. I need to adjust my camera setup. All right, this one says splitting the triangle with sides of dilation. Triangle ABC, the big one, is a dilation of triangle AMN, this one. And then we have some questions we're gonna ask about that. Before I do this, I'm just gonna kind of engage with the picture a little bit, see what I see here. So I see the little triangle inside the big triangle. And I see we have from A to C is 3. That might be helpful. And from A to B is 1.8 plus 3.6. All right, and I don't have a calculator, so I have to do this by hand. 1.8 plus 3.6, 8, 9, 10, 11, 12, 13, 14. 3, 4, 5, 5.4. That number might be helpful. And then we have a 6 on the bottom. Another thing that might be helpful for this problem is to actually draw out 2 separate triangles. So I'm going to do that. I'm not going to do it to scale. I'll just have the big one and the little one. Sometimes that helps me see the proportions more easily. So the big one is A, B, C. The little one is A, M, N. And I can put my numbers back on here. That's 3, that's 5.4, that's 6. This is 1, this is 1.8, this is we don't know. We could also mark the angles that are the same. Angle A is the same as itself. And angle C would match up with angle N. All right, I've engaged with the picture. That makes sense to me. Now I'm going to read my questions. It says, what is the scale factor? How long is segment MN? And what must be true about MN and BC? Let's start with the scale factor. So the triangles are similar and we want to know what's the ratio. How do we get one to the other? So I'm going to do the big triangle divided by the little triangle, and I have 3 to 1 right here. So I'm going to do I'm going to do scale factor, big triangle divided by little triangle. And I see the big triangle has 3 and the little triangle has 1. Okay, I can check that. So it seems like the scale factor is 3 to 1. I can check that by doing 5.4 on the big triangle and 1.8 on the little triangle. And then I can divide these, and it's true that 5.4 is 3 times bigger. So the scale factor, K, sometimes we use K for scale factor, is equal to 3. So that's the answer for A. All right, for B, we want to find out how long is segment MN. That was the missing one, MN. I can use what I was doing with scale factor to continue this relationship and then solve for the missing piece. So I'm going to do big triangle is 6 over MN, which is unknown. I'm just going to put MN here. And I'm going to take this one and this one to use as my proportion. So 3 is to 1, the same way 6 is to MN. Some of you can just see it. And what does MN have to be if this triangle, well, if this triangle is 3 times this triangle? What number has to be here if I multiply by 3 and I get to 6? Another way to do it is cross products. So 3 times MN is equal to 6 times 1. Divide both sides by 3. So what we really need to know is 6 divided by 3. Because this one is 1/3 of the size. Sorry, this one's 1/3 of the size. This one's times 3 this side. So 6 divided by 3 is 2. So MN, that's the answer for B, is 2. All right, the last question is what must be true about MN and BC? I'm going to go for this one. I'm going to go back up to here. What must be true about MN and BC? What we're trying to get, there's actually a couple answers about that. So we'll do both. Something we wrote in our notes is that MN is going to be in the same proportion to BC. The other thing we know is that MN is always going to be parallel to BC. So for the answer to C, I'm going to put MN must be parallel to BC. Oops, you can't see that. Or if you want to write the notation, you could say MN is parallel to BC. You could also say that it cuts it proportionally, but let's just stay with that for the answer. Okay, let's take a look at the back. Give me a moment to readjust this. Okay, it says connecting similarity and transformations, describe a sequence of rigid motions and dilations that takes square EFGH to square ABCD. Okay, so we're starting with this one. We need to go from here over to here. All right. With the scale factor, or with the dilation, the first move is to dilate it. So we're going to have some steps here. It might be easy just to label the steps. We're trying to use I think I'll do it here. We're trying to use the vocabulary, the words that we've been talking about, the words that have been on the board. So we're going to start with dilate, EFGH, by a scale factor of every 2 on here needs to go to what? Every 2 on here has to be bigger. So we're going from 2 to 5. I'm going to use E as my center of dilation because that makes sense to me. So every 2 on here is going to go to 5 on here. So this is going to be my F prime. This is going to be my H prime. This is going to be my G prime. So the scale factor is, actually it's 5/2, or 2.5 times bigger. So for dilation, we need the scale factor. We also need the point of dilation. Using point E as the center of dilation. Okay, so now we have triangle E, or E prime, F prime, G prime, H prime, and we want to get that to A, B, C, D. So the next thing I would probably do is I would translate. So step 2 is to translate E, and we want E to match up with A. So if I had tracing paper, I could show this better, but we're going to move the whole thing so that E translates onto A. And it would look something like that, where this is going to be F prime, this is going to be G double prime, actually, this will be H double prime, and this will be E prime. We'll call it E double prime. Okay, so let's write that step out. Translate E prime, F prime, G prime, H prime on the directed line segment E prime A. Okay, so now I've got it over there, and I think you can see the next step. So we want F to land on B. So we want F to land on B. And I give you a hint right here. What is this that I'm going to do next? I'm going to take E and I'm going to put it on, sorry, I'm going to take F prime and I'm going to go put it on B. What's that look like? Looks like a rotation to me. So the last step, if we want to get this triangle onto that triangle, is to rotate. I'm going to call this E double prime, F double prime, G double prime, H double prime. And what's the angle of rotation? We want to go from F double prime until it's on AB. So let's use the one that says until E double prime, F double prime is on ray AB. Okay, that just says I'm going to rotate until EF stops at AB. Okay, so therefore EFGH is similar to ABCD. All right, yeah, that's a good way to do that one. And then last question, what stays the same in similar figures and what is different? We talked about this in class a little bit. You want to do this problem, but you also want to show an example because there's a lot of room down here for you to show your thinking. You can also tell me other things that you learned in this section if you want some bonus points. So I'm just going to start with a picture because it's easier to talk about. And triangle is the most important shape in this class, right triangle specifically. So I'm going to draw two triangles. I'm going to be tricky and use parallel lines so that my triangles look more similar. No rotation involved here. Right, and we can, so I made myself my own example. I'm going to be boring and call, I won't be boring. I'm going to call this one CAT, and I'm going to call this one DOG. Okay, so the two, what stays the same? In similar figures, if I want to answer the question completely, in similar figures, use a complete sentence. The angles, let's use a math word, the corresponding angles stay the same and are congruent. Oh, I used a math symbol. How exciting. Okay, and then if we want to really drive that home, we could say angle C is congruent to angle D. We could mark it to show the person we know what's going on. Okay, we could say angle A is congruent to angle O. We could mark it, do the two little marks. And the last one, we could say angle T is congruent to angle G. You really want to have a complete answer, you can say no matter what the size difference, the angles have the same measure. In similar figures, even though you got a big one and a small one, the angles are the same amount of opening. If I got a protractor measured this one, got a protractor measured this one, it would have the same number that goes with both. All right, now let's do the next part. I'm kind of running out of room here. What is different? In similar figures, the sides are different lengths. In similar figures, the sides are different lengths. So we could also say they are proportional. So in this figure, we could say CA. Well, I'm going to keep doing big triangle over little triangle. Divided by DO is the same as AT. Divided by OG is the same as TC. Divided by GD. All right, that's a pretty good answer. That'll get you full credit. Another thing we talked about in class is what stays the same is the classification of the shape. So if this is a scalene triangle, and that's would also have to be a scalene triangle. All right, I hope this helps. Sorry I'm not there, and I will see you tomorrow.